Hey everyone, moving on to the first example of our derivative graph, we have this y equals to fx graph, and as promised, there are oblique asymptote, this time round with gradient k. So we have y equals plus minus kx as our asymptotes, and this particular graph passes through the point at 0a, and this is a turning point. Alright, now you can kind of see it as a top part of a north-south hyperbola, and I think you guys should know that it is fine. Okay, that is quite familiar to you guys. All right, so let's draw the derivative graph, and it's rather simple because it's only one continuous graph. We now just need to figure out how it starts and how it ends by the turning point. All right, so let's say before the turning point at 0a, well, first of all, if you want to draw the turning point, it will intersect at the graph at 0, 0. Okay, then from there, what happens? Now, the gradient of the graph, you notice, starts from 0 and tends towards infinity. However, the graph then follows the oblique asymptote at minus kx. Similar idea to the graph tending towards a particular y value. This now tends towards a linear line minus kx and will behave like a linear line. As such, this gradient here tends towards minus k. As such, we have a y asymptote at y equals to minus k, and your graph, while looking at this, it is increasing and then it becomes constant. So your graph would actually have a decreasing gradient and it will tend towards minus k. Thereafter, what happens? Now, we're done with the left side. Now it's time for us to consider to the right. Similar logic, as x tends towards infinity, your graph would behave a lot like y equals to kx and would therefore have the gradient tending towards y equals to k. As such, we have the gradient tending towards y equals to k, and being a continuous graph, it would then continue on and tend towards k. So this is a derivative graph when involving oblique asymptotes.